So apologies from Lorna Cole, who can't be here because she's basically ill and didn't want to pass everything on to you guys. So I'm just really going to give an indication about pollinators and why, there is this big media hoo-ha about protecting pollinators, protecting bees, and obviously getting rid of certain pesticides. But they do really play an important role. And as I'm mentioning, the stuff in the media, you can open any sort of paper these days, and there's always these headlines about bees and pesticides getting removed, bee decline, pollinator decline, and so on. And some of the more eagle-eyed of you might have seen this headline just before Christmas, which was about fungicides and decline of bees in the USA. And this morning, if you were paying attention, you'd have heard chlorothalonil mentioned a fair bit by Neil and by Fiona, being very important for managing resistance in cereals. And chlorothalonil is the fungicide that's being implicated for doing away with the bees in the US. So I'm hoping that the crosshairs don't now move onto chlorothalonil, but it's always a risk that the media are going to have a bit of a field day with that. So why the concern about pollinators, particularly, not just bees? If you think way back in 1980, this is a sort of index of how diverse, how many pollinator species and so on there were in the UK. And, fair bit, but really over the last 30, 40 years or so, 30 years even, there's been this gradual decline in pollinators. And why the concern? So what? Okay, they've gone down a bit, so what? Farmland birds have been going down, all this sort of stuff. Well, pollinators really are crucial, and it's because there's such a diverse range of pollinators. So, for example, you've got this pollinator here, which is called a Cuckoo Bumble Bee, and it's just like the bird. It finds another bumblebee species nest, boots out that bumblebee, and basically takes it over. Then you've got another one here, which has got this very big snout, but this is my favorite one here. That's got a very long tongue, basically, and it's got an unpronounceable Latin name, but its common name is the Heineken Bumblebee, because it can reach the parts other bees can't reach with its long tongue. And then you've got the kind of this other bumblebee here, and I don't know if you can see very well in the picture, but big, huge nectar sacs or pollen sacs on its back legs. And that's what the bees and other pollinators do, is they get rewarded with the nectar, and with the bees also the pollen, but then they're also pollinating crops, pollinating plants, and that has a significant effect on yield. Now, I didn't realize that Einstein was a insect expert, so I'm in good company, maybe not. But he said way back when, no bees, no food for mankind. The bee is the basis for life on this earth. Now, okay, he's maybe being a bit kind of exaggerating a bit there, but when you think about it, increased fruit set, quality, and yield of 75% of worldwide crops are down to pollination by insects. And in the UK, somebody's worked out that equates to about £600 million a year that pollinators contribute in terms of UK agriculture. Now, if we lost all the pollinators completely and we had to hand pollinate crops, so that same person there has worked out it would cost about 1.8 billion a year. So pollinators really do play a crucial role, and this is what you get. Manky strawberries, if they're not pollinated by insects, really crappy raspberries, and dodgy-looking peas and beans, whereas this is what we want: good, fat, juicy fruit and good yield. And that is all down to the insect pollination contributing to that. So we're all going to play a game now. Bruce C., R.I.P. Who remembers Play Your Cards Right from the 1980s? Hopefully the rules are going to be quite obvious. This is all about what's the contribution of insect pollinators in terms of percentage increase in yield. So if you look at peas and beans, they contribute 25% to the yield of these crops. So, raspberries, higher or lower? Oh, come on, bit more oomph. Higher, higher. Yay, for 45%. Well done. Good game. Now, apples, higher or lower than 45%? Ooh, the lowers seem to be going for it. 85%. And finally, that's meant to be oilseed rape, higher or lower than 85%? A few people saying higher here. It's only 25%. So, the cynics could argue that all that fuss about pollinators and oilseed rape and bees and stuff, and that they're only contributing 25% extra yield. Should be making much more of a fuss about the fruit. So hopefully you get an idea that pollinators do have a big role to play in actually maximizing yield and quality of crops. Now we've got a PhD student, Lorna and I, based down in Edinburgh, and he's looking at oilseed rape and the contribution that pollinators play, and particularly looking at different varieties of oilseed rape and also the difference between hybrid varieties and conventional varieties. And with the hybrid varieties, you don't need to worry too much. He's basically been putting bags over the rape to stop the insects pollinating it and then measuring seed weight. And with the hybrid varieties, there's no difference if you stop the insect pollination, no real difference in the yield. But there is a difference if you stop the insects pollinating conventional varieties. Now, there is a lot of variability there. Some varieties really don't respond very well if you stop the pollinators getting to them. So this work is ongoing, and hopefully in a couple of years' time, we'll be able to give you a bit more info, maybe even naming specific varieties. So the other thing is, why do we need a whole range of pollinators? Why don't we just have one group or just a small handful of pollinators? If you look at oilseed rape flowers, they're open, so it's very easy for a whole range of different pollinator insects to get to the pollen and to get to the nectar. So they're quite easy to pollinate. Whereas you have a crop like field beans here, where the flowers are much more kind of funnel-shaped. There's only a select few types of pollinators that can get down, the ones with the long tongues, basically, to get down to where the nectar is and to pollinate those. So when you look at the range of different types of pollinators in oilseed rape, you've got mainly bumblebees, which is the blue there. Sorry, mainly other. Yep. Small number of bumblebees, honeybees, and other insects. Whereas in the field beans, it's very much the bumblebees that do the business in field beans. So what can we do, or what can you do as growers and agronomists to encourage pollinators? And it's basically just like humans, we need food and shelter. And exactly what you need for bumblebees, they need nesting sites and overwintering sites for the queens. For butterflies, which are also pollinators, you need something for the grubs, the caterpillars, to eat, shelter, overwintering. And then the hoverflies, huge range of hoverfly species. Some of them live in dead wood. Some of them are predators, so they actually do pest control for us as well. Some of them eat fungi, and others actually eat cow shit. So it's, a very diverse range, but they all pollinate crops. So what they really need is a continuous supply of pollen and nectar throughout the season to keep them ticking over. It's no good if you've got a crop of beans that only flowers for like a 2-week period and there's nothing else there, because the pollinators are not going to be there because there's nothing else for them to eat before the crop gets into flower. So you need something to be flowering all the time, or a range of flowering crop plants. So with the increase of the EFAs now in Scotland and also in England, where you can put in buffer strips, field margins, end-fixing crops, cover crops, which Robin's going to talk about shortly, fallow, and now you've got agroforestry and hedges, there's money, I suppose, there now to set up some of these areas which can also provide resources for the pollinators. So a wildflower strip, for example, will provide a great source of things for pollinators, for food. And a study that was done in England just 2 or 3 years ago now, where it was a farm which had a rape, wheat, field beans rotation, and they did a comparison between having no wildlife margins in the field, 3% of the crop margin as a wildlife habitat, and this is a range of wildflowers and stuff, something that will provide pollen and nectar throughout the season, and 8% of crop margins as a wildlife habitat. And in the beans, with the 3% crop margin, you had a 25% increase in yield. 35% increase in yield when you up the crop margins to 8%. And that's all down to the fact that you've brought in a broader range of pollinators, which are then repaying you by pollinating the field beans. And those increases in yield basically counterbalance the yield loss because you've taken 8 or 3% of the land out of production. And you're also ticking that great environmental box that Michael Gove is going to be introducing, as he says, or so he claims, where you're encouraging wildlife and wildlife habitats. So SRUC is involved in a couple of farms, one up this neck of the woods with the Soil Association farm. I'm not exactly sure, I've never been there, but it's quite close to here, I believe. And then you've also got the Monitor farm at Edinburgh, or near Edinburgh, Preston Hall, where Lorna particularly is looking at wildflower habitats and measuring things like the beneficial insects, looking at the insects which are in field margins in the crop, looking at the natural enemies that are being found and whether they're eating aphids, looking at the pollination success in the crops on those farms, and obviously relating that then to yield. So again, we hope to kind of try and get the same results that was found in that English example where you provide a habitat for these pollinators and they repay you by boosting the quality and the yield of your crop. So there's a lot of people here to thank. Bizarrely, I don't think Lorna's picture's not up there. Oh, yeah. Is she? Can you see her, Robin? But yeah, Lorna's done a lot of this work, and she's the one really who should take most of the credit. Okay, thank you very much.